Define the term functional group. So it is an atom or a group of atoms that form the center of chemical activity in the molecule. Name the functional group in compound W. So W over here has got a double bond in it, so it is an alkene. Identify the, well, I suppose if you said a double bond, that is also the functional group, I suppose. Identify the type of reaction occurring in reaction P. So what's changed is the bromine, it was all single bonds, it's now formed a double bond, and we've eliminated a hydrogen and a bromine have been taken away from that. So it's an elimination reaction, but it is a particular elimination reaction. It is a dehydrohalogenation, because we've got rid of a hydro and a halogen. Dehydrohalogenation. Name reaction R, where I am taking that double bond and I am obviously going to create an alcohol, so I'm going to add a hydrogen on there and I'm going to add an OH on there. So in total, what have I added onto there? I have added a water, which is a hydration. I would have accepted addition. I suppose I should just write dehydrohalogenation over there. Right. While the write the structural formula for alcohol Y. So taking a look there, we've now opened up this double bond over here, and we need to put those on. So if I'm going to draw that out, it will look something like this. We will still have 4 carbons, and we'll have the alcohol group. If you had put that alcohol group onto this carbon, it would have been equally satisfactory. Name reaction S. When I have got an alcohol joining with a carboxylic acid in the presence of sulfuric acid, that is actually a esterification. I am making an ester. On account of the fact that you're brand new at this, I kind of accepted a hydration, because it's kind of like or dehydration, because you kind of do get rid of water in the process. But it's not really a dehydration reaction, it's an esterification reaction. What is our UPAC name of compound Z? Well, I have got 1, 2, 3, 4. So it's on the alcohol, it's butyl, the alcohol comes first, then ethanoic acid, ethanoate. Compare the viscosities of compound W and X. Fully explain your answer. Well, W is going to be an alkene. So this is W, it is an alkene, and that means that it is pretty non-polar in nature with weak intermolecular forces. Therefore, a low melting point and boiling point. Versus compound X, which is an alcohol. And an alcohol has a polar OH group. This results in hydrogen bond forces, which are fairly strong intermolecular forces. And therefore a high boiling point. Oh no, we are not asked about boiling points, we are asked about viscosities. If they're highly attracted to each other, high viscosity. Sorry, this would also have been a low viscosity. Because the particles are poorly attracted to one another, here they are gloopy because they stick together quite well. Define the term isomer. Isomers are compounds that have the same molecular formula and different structural formulae. Using structural formulae, show a structural isomer of the compound W and define the type of structural formula you have drawn. Remember, there are a number of different structural formulae. There are chain isomers, you get positional isomers, and you get functional isomers. And there were 2 things that you could have easily done with compound W. It had a double bond in it, so you needed to kind of keep that double bond in to keep the same number of atoms, and you land up with 2 possibilities. So in the chain isomer, I changed the chain. I've now got a chain length of 3 instead of 4, and I've put a methyl group hanging off. Be careful with your number of hydrogens. Over here, in a positional isomer, I've moved the double bond from carbon number 1 onto carbon number 2. And I identify that as a positional isomer, and I identify that as a chain isomer. 4 primary alcohols are used to investigate the effect of number of carbons in an alcohol on solubility. The results obtained are shown in the table. Bigger molecule, bigger, so this is 4 carbons, 5 carbons, 6 carbons, and 7 carbons. And as you can see, they are getting increasingly less soluble. Describe the relationship between the number of carbons in alcohol and its solubility. So you needed to say longer chain, less soluble. Explain this by referring to intermolecular forces and the polarity present between the molecules. So, if there is a long chain, we have stronger IMF due to more electron cloud, or bigger, if you prefer, electron cloud, and greater electron cloud wobble. Therefore, bigger molecules it will be more difficult for them to dissolve because they've got stronger, their own IMFs, their own intermolecular forces are stronger. Also notice that dissolving in water, that both water and alcohol have both got hydrogen bond forces, so they're similar strength forces. An isomer of pentanol and 2,2-dimethyl propanol have this. An isomer of the pentanol has a solubility given over there. Write down the structural formula of that particularly big thing, and it's going to look something like this. So we have got a 3-carbon chain with 2 methyl groups hanging off carbon number 2, and we've still got the alcohol group on carbon number 1. Explain why it has a higher solubility, and it links to the fact that it's got a smaller surface area. Therefore, weaker intermolecular forces, because there's less points of contact for intermolecular forces with a smaller surface area than a long chain of pentanol, and therefore more soluble.